All right, class. Had a choice this week. Since we're testing, said, well, if you want, you can just hold class on Thursday since we're not meeting on Tuesday. And I went, I can probably do better for that. Instead of making you come back Thursday, Thursday is just going to be an asynchronous day to come back if you need help. I want you to have your lesson today. So I went back into my archives since I video all my classes, and I pulled out last year's video of this exact same lesson. So that's what I've got for you today. Watch this video from last year, and Thursday is just going to be a normal asynchronous day. Come if you need help. Come if your grade's below 70%. Otherwise, this should show you everything that I would cover in class. And of course, you have the lesson inbox to look at. All right, enjoy Past Me right here.
Now let's see how to solve rational equations. It's great. We've talked about asymptotes and all these other things about rational equations, but how do we actually solve it? And we're going to look at this little video of these two brothers painting their room. Make it big, make it bigger. It's only a minute 24.
Tom and Huck's family just moved into a new home. Tom and Huck each got their own bedroom in the basement, along with a shared area in between. All three rooms, the two bedrooms and the shared area, are the exact same size. Tom paints his room blue to match his comforter. It takes him 2 hours. Huck paints his room green to match his laptop. It takes him 3 hours. They decide to paint the shared room together, but how long will it take? It must take less than 2 hours because Tom can do it alone in 2 hours, but Huck is helping him. You can solve the problem by first thinking about what happens in just 1 hour. In 1 hour, Tom can paint half the room because it would take him 2 hours to paint it all. Similarly, in just 1 hour, Huck can paint 1/3 of the room, but you don't know how many hours it will take with them working together, so call the number of hours X. If you add the amount of work that each of them can do separately in an hour, you find the proportion of the room that they can paint in 1 hour. So you can write 1/2 plus 1/3 equals 1 over x. Because this equation has an unknown in the denominator, it is a rational equation. Do you know how to solve it?
Well, not yet necessarily, but we'll get there. Oh, I like this little quiz they have on page 1. This is a very short lesson, by the way, because this just seems like it's way too easy. What number goes in this box? Type the missing number in each box complete. So what number would we put here? Blank over 2 equals 3 over 2. You're like, that's a trick question, right, Mr. Brock? Blank over 2 equals 3 over 2. Is it 7? 7 over 2 equals 3? No. It's not a trick question. 3 over 2 equals 3 over 2. That's right. Elijah was not going to be tricked. He was not. It is that simple on this little quiz thing here they put on page 1. I love it. Here's another one. What over 7 equals 9 over 7? This is just the beginning questions to make sure you're actually awake and functioning, because yes, 9 over 7 equals 9 over 7. But now they do get a little trickier. Yes, 9/7 equals 9/7. Nothing else would work. Now this gets a little trickier. Blank 17ths plus 1/17 equals 8/17. Do you remember how to add fractions? If you have the same denominator, you just add the numerators. You can totally ignore the 17s because they're all the same. So you can totally ignore them. So blank plus 1 equals 8. Elijah's not going to be fooled. Yes, 7/17 plus 1/17 equals 8/17. So it is a good refresher to remember how adding fractions work and subtracting fractions. You have to have the same denominator. Blank sixth minus 1/6 equals 2/6. They all have the same denominator. So it is 3/6. Job, Jonathan. 3/6 minus 1/6 is 2/6. That's just a refresher because when solving rational equations, we have to have the same denominator if we're doing something like that. So, yeah. So it says you can just do x plus 1 equals 8 because they have the same denominators. All right, let's look at this. We're going to learn what reasons justify a solution and how do they apply in the real world. So a rational expression is just a definition here. It's fractions that have a polynomial in the numerator and denominator. 5x plus 35 over 5x, or x squared plus 6x minus 27 over x plus 9. Rational equations, if it has the word equation, there has to be an equal sign. And they have rational items like 8 over x. There's got to be an x in the denominator to be a rational equation. But the word equation means there's an equals. Equal, equate, equations. All right. So, let's work this together. I'm going to work this one just to kind of refresh how we do this. Okay, so when we are finding a solution to a rational equation, we have to have the same denominator. So what would the common denominator be between x and 4? Well, 4x would be the common denominator, right? That includes both. So on this side, we have to multiply by 4 over 4. On this side, we have to multiply by x over x. Now, what are we multiplying by? We're multiplying by 1. Right? 4 over 4 is 1. X over x is 1, regardless of what x is, unless it's 0. But we're not talking about it at 0 because it can't be 0. It's in the denominator. So this just multiplies by 1. So this is legal mathematically, right? We can multiply anything by 1, and we multiply into both sides by the same thing. We're multiplying both sides by 1. So when we do that, now we've got 8 over 4x. And over here, we've got 3x over 4x. Okay. So great. If these are equal to each other, because it says right there, they're equal to each other. To solve this, we would cross multiply, right? 4x times 3x is be 12x squared. 8 times 4x, now it equals 32x. So far, not bad. If two fractions are equal to each other, it's legal to cross multiply. Can't do it just any time, but if they're equal to each other. So now we want to solve this. This is a quadratic equation, right? We got that. We need to move everything to one side. So we got 12x squared minus 32x equals 0. So we factor it. See what factors we can get out of there. Well, there is a 2 for sure, and that may be it. And there's an x. Both of those terms have an x. If we pull 2x out of there, that leaves us with a 6x. Oh, we can pull a 4 out of there. Yeah. How about a 4? That's better. 4 out of 12 is 3x. That's as small as it gets. And if we pull 4x out of 32x, it's 8. Okay, so we factored out a 4x. This is as small as it gets. It can't be factored anymore. So to find the solutions, we take each of these. If this is 0, then the multiply these together is 0. If this is 0, multiplying those together equals 0. So one of those or both of those could be a 0. So 4x equals 0. 3x minus 8 equals 0. So the two solutions we get when we divide by 4, x equals 0 plus 8. 3x equals 8. X equals 8/3. Quadratic equation. We expected to get two solutions, right? With the quadratic equation, you always generally get two solutions. But here is where radical equations can mess you up. If we have two solutions, we need to go back to the original equation, 2 over x equals 3/4, and test them. Let's take our first solution. 2 over 0 equals 3 over 4. Wait a minute, there's a problem there. 2 over 0 does not equal 3/4 because 2 over 0 doesn't even exist. We have to throw this out. This is an extraneous solution. Extraneous solution. It is a solution. The math works. It is a solution to this problem. But with the original equation, it doesn't work. It's an extraneous solution. So you will get some solutions that you have to throw out because for the original equation, it's not true. How about this one? 2 over 8/3 equals 3/4. Like, wait a minute, a fraction under a fraction? We have to get rid of a fraction under a fraction. So to get rid of 3/8, you have to multiply, 8/3. 8/3. I'm sorry, it was right. It was 8/3, so I'm going by 3/8. So we're multiplying by 3/8 over 3/8, which is just 1. But this now, 8/3 times 3/8 is 24 over 24 or 1. So that gets rid of the bottom because anything over 1 is just 1. So that means 2 times 3 is 6/8. 2 times 3/8 is 6/8. So this simplifies to 6/8. And 6/8 does equal 3/4. So this is a good solution. Because when we turn that over, multiply by 3/8, it simplifies to 6/8, which 6/8 is 3/4. So you have to check because a lot of times you will get an extraneous solution when you are solving any kind of radical expression. And this has the steps. If you click this little arrow here, it says multiply by 4 over 4, x over x. So that gets where we were there. Then they cross multiplied to get what we got, the 32x equals 12x squared. Then they set it equal to 0, factored out the 4x like we did to come up with their two solutions, x equals 0, x equals 8/3. Substitute the 0 in. It doesn't work. It's an extraneous solution. That's a solution to an equation that does not fit the requirements of the original equation. So we throw that one out. And then they test the second one. And they just jumped straight from 2 over 8/3 to 6/8. I did the steps in between. But 2 divided by 8/3 is 6/8. And it does equal us. So it's confirmed solution. All right. I think this is the last page of the lesson. There's only 4 pages total. So here is a couple of word problems. And then the lesson summary is right there. So like I say, that's the end of the lesson. Find the common denominator, simplify it, solve for the variable, and then check to see if you got to throw any of those out. Because you got to reject anything that would make the denominator equal to 0. All right, so I'm going to work one of these with you. It does have how to do it underneath each of these little tabs. But let's work this one together, and I'll show you how do we solve a rational equation when we just have this word problem. So the math club at school is 70% girls. Okay. So the first thing you do is say, okay, we're going to say X will be the number of boys. And the girls would be 2 times the boys plus 5. Because that's what it told us. There's 5 more than twice the number of boys. And 70% girls, which means there's 30% boys in the math club. Then we have to set up the equation. So we can do that. Let's do it like this. So if x equals the boys, x would equal 30% on top. So 30. I'll just put the 30. We don't need the percent. X over 2x plus 5. It's the ratio of boys to girls. The ratio of boys to girls is 30 to 70. And the boys is x and the girls is 2x plus 5. Then it wants us to solve that. Well, we can cross multiply. Since they're equal to each other, it only works when they're equal to each other. So 70x equals 30 times 2x plus 5. All right, and we can simplify that. So 70x equals, let's distribute that, 30x plus 150. Move this over. Oh, that's 60. I did that wrong. 30 times 2. There's a 2 there. 60x. Subtract 60x. So 10x equals 150. So x equals 15. So when we solved it, x equals 15. Does that work? Well, x was the boys. So 15 boys. And the girls were 2x plus 5. So 2 times 15 plus 5. 2 times 15 is 30 plus 5. 35 girls. Girls. I don't need a T. Okay. Is that 70% to 30%? Add those together, there's 50. 50 times 70% is 35. 50 times 30% is 15. So when we check it, those work out. Let's see how they did it. X, 2x plus 5, 70%, 30%. They set up the x over 2x plus 5. And then, let's see, multiply both. They did the common denominator, but they canceled out the common denominator to end up with the same thing I did. Because they multiplied by the whole denominator. 70 times 2x plus 5. But the 2x plus 5s cancel out. 70 times 2x, and the 70s cancel out. So they basically cross multiplied. It's the same thing as multiplying both sides by the denominator. 70x equals 60x plus 50. 10x, x equals 15. All right. There's practice problems. There's another example you can go through. So you can try that yourself on paper and then check their example to see if you did the same. All right. I want you to solve 6 over x equals 10 over 15. And then you can check your answer. 3 problems there. 1 over 2x minus 1 equals 3/9. Check your answer. There's a second there. Create a rational expression. In the aquarium, 90% of the fish are blue. The rest are red. The blue are 10 more than twice the number of red. Can you set up an equation to solve? That's the tricky part, setting up the equation. There's the equation. And there's 2 of those for you to try. And there's the equation. All right. That's the last, because the page 4 just says, read the lesson, do the essential questions. All right, so let's look at the assignment that goes with this one. Start. Choose the equation that goes with this problem. So it gives you a word problem, and you have to figure out which one of those equations is how to set it up. Here's one you solve for x. Here's one you solve for x. Here's one you solve for x. And this one is another problem to set up, and you actually have to work the problem here. So this one you're setting up and working. 5 problems. 5 problems. All right, guys. Vertical asymptotes, horizontal asymptotes, and how to solve the problems. And then next week, we're going to test on rationals. So we're going to be done with it really quick. And then we'll start something else in 2 weeks. So This week, it's an A day Friday. So we do not have class on Friday. We will only have class on Thursday. So if you want to work on this before Thursday, that's great. So if you have problems, you can come to class Thursday and say, Mr. Brock, I don't get it. Can you help me? Absolutely. If your grade is below 70%, then you have to come Thursday. I will see you Thursday. But otherwise, if you don't need help and your grade's over 70%, I'll see you in April, because that's next Tuesday. We'll be in April by next week. So, all right, guys, I'm going to let you go. Have a great rest of your day. I do have the grades updated for your grade checks and advisory. So have a good one.